Today we're going to talk about relations and functions. Remember to take notes on the video and answer the survey questions at the end. A relation between two variables x and y is a set of ordered pairs. An ordered pair consists of an x and a y coordinate. A relation may be viewed as ordered pairs, mapping design, table, equations, or written in sentences. X values are inputs, domain, and independent variables. Y values are outputs, range, and dependent variables. Let's look at example 1. What is the domain and range of this relation? The domain is the x coordinates, remember 0, 1, 2, 3, 4, and 5. What is the range? That's the y coordinates, -5, -4, -3, -2, -1, and 0. Example 2. What is the domain and range of this relation? The domain is the inputs 4, -5, 0, 9, and -1. What is the range? That's -2 and 7, the outputs. Domain is inputs or x values, range is outputs or y values. Is a relation a function? So what is a function? According to the textbook, a function is a relation in which every input is paired with exactly one output. A way I think of a function is in my math class, every student must receive a grade. So that is the input. A student cannot earn an A and a B. They receive only one grade, the output. So for every input, there is only one output. Is a relation a function? Focus on the x coordinates when given a relation. If the set of ordered pairs have different x coordinates, it is a function. If the set of ordered pairs has the same x coordinates and different y coordinates, it is not a function. Y coordinates have no bearings in determining functions. Let's look at example 3. Is it a function? Look at the x coordinates. Yes, it is. Each input has one output. Let's look at example 4. Is this a function? Look at the x coordinates. No, it's not. The input of 0 outputs -8 and outputs 5. That's saying the student can get an A and the student can get a B. That's not possible for a function. Which mapping represents a function? Choice 1. Each input has exactly one output. In choice 2, -1 has two outputs. That's a student getting an A and a B in the math class. It's not possible for a function. Which mapping represents a function? That would be B. Each input has one output. Even though it's the same output, they all have one. In example A, one input has 3 different outputs. One student has 3 different grades. The vertical line test. A relation is a function if a vertical line drawn through its graph passes through only one point, aka the pencil test. Take a pencil and move it from left to right. If it crosses more than one point, it is not a function. So let's move our pencil along the graph to see if it's a function. It only hits at one point at any given time, so it is a function. Let's see if this one's a function. If we move our pencil from across the graph from left to right, it hits at 2 spots on one line. It is not a function. Alright, let's see if let's see the functions and then determine the domain and range. This is a discrete function. That means we can't draw it without picking our pencil up. To determine the domain and range, we look at each point and see the x coordinate for the domain. So our domain is -7, 1, 5, right here, 7, 8, and 10. Our range would be our y coordinates, so 1, 0, -7 down here, 5 up here, and 2 and 8. Is this one continuous or discrete? It's continuous. We can draw it without picking up our pencil. And we write this one similar to we do interval notation. -8 over here, including -8, that's what the bracket means, and it stops at +8, and we include +8 or the bracket over here. We look at the range, and it starts at -6 down here, including 6, and see it's touching there, so we're going to include it with a bracket, and it stops at a +6 up here, include it with a bracket. Is this continuous or discrete? It's continuous. The domain, it starts at 0 and moves to 45. It starts at 0 here, moves to 45 over here on the x, because we're looking at domain, so we're looking at x plane. Look at the range, we're looking at the y coordinate, so we're at 10 and it stops at 70. Let's look at function notation. F of x means the function of x and is read f of x. F of x equals 2x plus 1 is written in function notation. The notation f of 1 means to replace x with 1, resulting in the function value. So anytime we see an x, we're going to put it with a 1, but we want to put parentheses in around it to make sure we know what we're inputting. So 2 times 1 plus 1 is going to be 3. Let's look at some more. So we have given g of x equals x squared minus 3. What is g of -2? G of -2, we're going to put a -2 wherever we see an x, and remember to put it in parentheses. So -2 squared minus 3, that's going to give us 1. Alright, given f of x equals 2x squared minus 3x, we're going to do the following ones. So f of 3 just means we're going to put a 3 wherever we see an x, and remember to put it in parentheses. So we get 2 times 3 squared minus 3 times 3. Remember order of operations. And we're going to get f of 3 equals 9. For b, we're just going to multiply the entire function by 3. So that's going to give us 6x squared minus 9x when we distribute the 3. And for c, we're going to input a 3x wherever we see x. So that's going to make, remember to put in parentheses, and that's going to make 2 times 3x squared minus 3x, and then order of operations to get 18x squared minus 9. Here's your survey questions. Have a great night.